Okay. Welcome, everybody. So I thought I should present something slightly different, which is, admittedly, it's a niche topic, but I think it's going to be interesting, and it's not a very big one. It has to do with how we deal with what is called storage attributes. Basically, whenever we upload a document, there are certain attributes that we have to upload with the file, which happens on the HTTP header. And these attributes are important for the storage to either understand, what the upload entails, or to maybe signal some extra information. And what that means is that in a normal scenario where you have a save, upload, and then return back to editing in a synchronous way, you would simply put these flags on the header and that's it. When the upload happens, you're done. If it fails, you try again and everything is fine and great. Of course, um, that's not the world we live in. We live in a world where the user doesn't want to stop editing. And indeed, we do everything we can to make the performance such that the saving and uploading happen in very smooth fashion. We do both saving and uploading asynchronously in the background, and we try to minimize the impact. Indeed, it's so smooth that users shouldn't notice that saving and uploading is happening. What that means is that the user can continue editing, which is perfect. It's great for the user, but for the technology behind all of that logic, it means we have more cases to deal with. Specifically, think of the scenario when we have saved a modified version of the document and we are uploading it, and the user is continuing editing. Maybe they hit save again, and we fail the upload. Now we have a second version of the file on disk that we have to upload. The tricky bit is that the attributes that I just mentioned might be different between these two versions. So what do we do in that case? Well, first of all, let me show you what the attributes are. They're fairly straightforward. We only have a few flags. Here they are in the attributes, in storage base attributes class. We have a flag that tells us whether we want to force the upload or not, meaning we want to override an older version. And this is important because the user is prompted when there is a conflict to either ignore the version that they were editing and respect the version that is in storage if it is different, or to override the one in storage with their own version if they think their own version is more up to date and basically worthy of storing rather than the one in storage already. Other than that, we have a flag that says if the version was modified by the user or not. And again, the user can save and upload without modification. And we have to tell the storage if there is a valuable modification here or not. The other flag is whether the save is happening through background autosave. Again, why is this important? Well, because the storage is trying to optimize its disk space and its resources. And in some cases, it might decide that it's going to either skip a version, or it is not going to store it in the database. It might just cache it. Again, the details of what the storage does is not really relevant, except that we do let the storage know that this is not a manual save. This is an automatic background save, right? And the next one is related to saving, and this one tells the storage that this is the final save we're doing before unloading the document. And you can imagine why this is important. For the storage that is trying to optimize its disk space and its resources, it is important to know that there won't be a subsequent save. And if it had skipped, for example, the previous version, it better save this one. And finally, we have some extra data that could be provided from the client. We just pass it through as is. I really don't know how much this is used in production, but it's there for our partners to benefit from it, and they can pass whatever extra information they need from the client, such as a context or something like that, all the way to their back end. And in some cases, that might help them, optimize their operations. So what I'm going to do in the next few minutes is basically show you what we do in exactly the scenario that I just described earlier, which is you have a save and upload that is happening in the background. And for whatever reason, it fails. Either it times out or there's a network hiccup. It really doesn't matter. And these settings now are old, right? And you have a newer version that you're saving, and its parameters might be different. And um, I guess the worst case scenario would be if a save that was being done because the user had made modifications and had manually saved fails, and the next one is an auto save and there is no user modifications. Why? Because the user didn't edit during the interim. So in that case, you don't want to upload to storage saying this is not user modified and this is auto save, right? Because that is clearly a lower priority than a version that is user modified and manually saved, right? That one you do want to store. But since the first one failed, the subsequent one has to inherit these properties, right? You see how this can get tricky. So I'm going to show you how we solve this problem. The way we solve it is we don't have a single attribute state. In fact, we have three of them, as you can see here. The way we do this is every time that we are working on a version, we are updating the next storage attributes. So whenever the user, for example, hits save or an autosave kicks in, it's the next storage attributes that we modify. And this one is really call it private, right? It's not what we pass on to the storage. The one that we pass to the storage is the current storage attributes. And when we're done, we save in the last storage attribute so that we can retry when there is a failure. This looks somewhat complicated. I appreciate it, but this is the nature of having asynchronous processes, and the fact that we need to figure out how to make sure that we don't lose these attributes or we don't incorrectly clobber them, meaning the newer value overriding the old value and then we lose the old value. So let me show you what we do with these. Whenever, I'm not going to go into too much details, but I'm going to give you the gist of it. Whenever we make finish the saving, and we know that there is a new version generated on disk. We need to merge the what is next storage attributes, which is what we're updating continuously, really, whenever there is any change. We merge that with the current storage attributes. And remember, the current storage attributes is the one that is going to be sent to the storage, right? And we reset the next one, meaning basically we move the current attributes over into the one that is going to be uploaded. But we do that in a way that we merge them. As I said, we don't want to override immediately. So as you can see, there's a bit of logic. It's fairly straightforward. We check that if the new attributes are stronger than the old attributes, and only then do we set the flags, right? We don't immediately override. That's the logic. And we do this when we save, we move from next to current, and you will see we do something very similar with the current. Here, when we finish uploading, we move from the actually, hold on. I'm going to show you what we do with the last, because the last one is the one that we hold while upload is in progress. So as you can see here, when we initiate the upload, what we do is we move from current into last. And the reason we do this is because if the user hits save again, we don't want to overwrite the current and lose basically what was being uploaded, right? Again, because these are asynchronous, the user can save at any point, uploading is happening in the background, and you can have overlaps between multiple of these, right? You can have a save followed by an upload, and then a save that overlaps with the upload, right? And the user obviously can modify at any point and hit save again. So the idea is that the when while we're uploading, the last storage attributes is the backup. It is what is being uploaded until the next upload starts. So this is basically how we move these attributes from next, which is what is being updated, into the current until we do the upload. And once we start the upload, we move from current into last. And finally, um, the current is reset and merged when the upload is finished, so that we bring it back when we have a failure. Otherwise, if we don't have a failure, we're all good. Um, and yes, you've seen this one. So that's the basics of it. Of course, you can see there is slightly more details in that there are error cases that we need to handle. But basically, by having these three states, we solve this problem in a very consistent, and I think it's elegant because it is very logical, and you can think of the three states as the three stages, right? Which is editing, updates next storage attributes, saving, which updates the current storage attributes, and uploading, which updates last storage attributes. And whenever there's a failure, the last storage attributes need to be taken into account to retry. So here is where we do that. When there is a failure, we go back and merge into the current so that the current would be used again when we do the uploading. And that's it. That's all I have for today.
Thank you, Ashod. Now, questions, guys. Justin question. Attila questions.
No questions, thank you.
Bayram. Kellen.
In practice, when do we see this happening most often? Is it like errors on our own side, or do people change? Other people like upload new versions like directly with Nextcloud? Is that where it arises?
Um, yeah. So uh, think about any integration um, that can have let's say either uh, unstable or unreliable, maybe network connection, or it times out, or it might, for whatever reason, temporarily reject the upload, say because the tokens have expired. So there are many scenarios, and in practice, we do see this every so often in the form of something is wrong. We either lost a version, or there's a version mismatch or something. And then if when you go back and try and investigate, it all comes down to the flags, and the integration was doing something with the flags that was non-trivial. And in that case, um, we have found in the past, and this is many years ago, we have found that in some of these scenarios, we were clobbering these flags, or they were simply being inaccurate simply because the newer state has changed things, but there is a version that we dropped in the middle, or the upload had failed and we didn't realize. So inadvertently, we've basically clobbered those flags. So we don't have the state of the storage, and that's the biggest problem. And we need to track the state of these flags on our own side separately, so that we make sure that when we pass it on, it is always going to contain the maximum information, right? I don't know how clear it was, how um, the fact that a version that is modified that failed, if you don't pass on the modified flag, the user modified flag in the subsequent upload, you could basically signal to the storage that there is no modification since the file was opened or last uploaded, at least, right? I don't know how clear that is, because that is the crux of the matter, right? um, that is a very bad issue, right? That we have
Yeah.
to
Yeah.
avoid. Makes sense. So, um, so in practice, yes, to answer your question succinctly, we do see this in the wild, and it's not common. It's very hard to track because it involves multiple systems. Often the states aren't really saved, especially if the log level is low. So it's really the kind of issue that um, requires hard analysis to understand that there is a fundamental issue and we need to handle it in a different way. You can't just have simple flags that are in the document and you just upload them, or include them in the upload, and you're done. That just doesn't work. And so you need something more complex. And I'm particularly happy with this solution, to be honest, and because I think it's elegant and it's easy to understand. Even though it's doing something somewhat complex, you can reason about it because it has very clear transition between the three states, and the merge function is the one that is being used. In fact, it's merge and reset, and I even considered merging these two, if you'd forgive the pun, into a single function where you would, merge two states into one, and then you would reset the source. But I thought explicit was better than implicit, right? So that you can see exactly what we're doing. We're moving the attributes over, and then we're clearing the old one. And we do this continuously whenever you save and upload.
Thank you, Ashod. That helps, Kellen. If you have more
Oh
questions.
yes, yes, very much so. Thanks.
Thank you. And here, Justin, write in the chat, async saving is highly desired in the desktop version as well. How much change was needed in core LibreOffice to handle async save for online? I imagine most of the code is online only.
That's a very good question, Justin. So I would say quite a bit of code, and it's not just the volume. It's um, how advanced, or how let's say sensitive the code is to um, you know not writing it properly. So Michael is the expert in this area. It's uh, um, pretty much all of that code is, as far as I know, is his own, and yeah, it's fairly advanced and fairly online specific for various reasons. Um, I suppose in principle you could do something similar for the desktop, but um, I fear the problem there is because I mean, in online you have a back end and you have a front end, and then you have the cool WSD server in the middle, right? There is a lot of asynchronicity, and there are natural latencies between these components. So it's harder to overwhelm the system. But on the desktop, I can imagine you can possibly, you know, get in trouble maybe if you try to save rapidly many times, and then it's your system really. If it becomes unstable, then you're in trouble. Whereas in online, we isolate things. We we monitor things. If something is taking too much resources, we can kill it. So it's a safer environment in a sense. I don't know really if I answered your question, but I would say technically it is possible. In practice, probably not worth it. But I don't know. Maybe somebody else has a better answer. Certainly, Michael
Well,
would probably have some opinions on this.
yeah, I think you did answer the question. You're basically saying that this is all online only code. In theory, it's possible, but it's not. I mean, you didn't have to modify core LibreOffice in order to get this functionality into online.
Um, yes, you're right. I mean, if there was any modifications, it might have been to avoid some sharp edges, things that is better done slightly different way, not necessarily to make this work. This works independent of the core, and it's really a matter of handling the threads correctly, and this the state and the connections back into col.la. So yeah, there were slight changes in that we need to shut down the threads before we do this asynchronous saving, for example, and you need to coordinate that with core. But beyond that, it's all in online. It's all in our domain.
Yeah, for core, rapidity isn't going to be terribly important. The main thing is just that the user can continue editing while a save is happening.
Yes,
So,
in some extreme cases, saving does take a proportionally long time, as big as the document is. That is true. Although in most cases, it's fast enough that even a few dozen pages would take a second or less. So it's not an issue unless you're editing a huge book.
or saving in
In,
ODF format.
Yes, possibly. Incidentally, for books, I don't know how common knowledge this is, but um, so some time ago, I found out that LibreOffice does support a way to split a large document into independent documents, and then you link them into a main or a master document. And basically, the individual chapters or sections, or however you want to split it, they're in different files. And so saving them is much faster. So when you save the edits, you're really only saving that section or that chapter of the book, or the document that you're working on. You're not really saving 1,000 pages. I don't know if this is used frequently, but it is specifically designed for large documents, and for collaborative editing, in the sense of different authors are working on different chapters, and I imagine they email each other. This is before the days that online was available. But that was the answer to, oh, it's taking 30 seconds to save my 1,500 page document. But in online, since we do this asynchronously, you can have 2,000 pages, and just continue editing just as well, because saving will take constant time. Every time it's going to be a few milliseconds, and you won't even notice it because it's all happening in the background.
Thanks, Ash.
Thank you, Ashod.
Thanks for the question.
Thank you, Justin. Cosmin, questions?
No questions. Thanks, Ash, for the presentation.
Thank you. And Darshan?
Thanks for attending.
Okay. Hussein, questions?
Yes. So what I wanted to ask is that just referring to your last statement about different sections of document. So what I was wondering is that we have, for example, database technology that DBMS software handles the storage stuff, and you only care about loading and say, let's say, querying in a higher level language. So I was wondering if by thinking about other architectures, or leveraging some means, um, that underlying code can be simplified, or let's say uh, using some ready-made technology or tool uh, can be instead of handling all of this stuff but by your code, because it's complicated and you have to deal with all sort of stuff. But then, for example, you let's say it this way: if theoretically the data was stored in a database, you have you were not forced to handle this stuff yourself. But as this is not the case, can you imagine some other way to handle stuff in order to simplify the code and simplify the things that you have to manage and you have to code and maintain?
You mean specifically for saving, or because you mentioned searching, I guess, at some point?
I'm just talking about alternative solutions, and if for storage, and if um, uh, searching is possible,
Yeah,
that's
I suppose
something.
you can. I mean, that would be a completely different approach to editing and creating documents, right? Yes, you could replace a traditional file format with a database, um, and that would basically solve the problem of saving and searching as well, because you can query the database in a more flexible way, I guess. Um, but then that's a completely different solution, one where the user doesn't own their data, and exporting becomes a bigger issue, because you still need to convert it somehow into, let's say, a printable format. And if you need to email it to people, that would also be, you would need an export function. But I mean, technically, it is possible. There are many similar problems that were solved by moving the logic into a database and adding a front end to it. Um, I think it's an interesting exercise in what can we do differently, and brainstorming about technology and so on. But I think that's not the problem we're trying to solve, or maybe not how we're solving it.
Okay, thank you.
Thank you for the question.
Thank you. Gogai questions? Okay, Joao questions?
No, no questions.
Miklos?
I would have one. I assume that you have to cover some of that COVID task, and I wonder if this is standalone enough that you could even unitize that, not like spin up the whole WSD and execute everything, but just extract this logic of merging these attributes in a way that that would be standalone, or would that even make sense? Or like, what are your thoughts there?
Good question. I think the logic of merging the attributes is straightforward enough that testing it would be trivial, and yes, you could do it. I don't think we have a test for that, simply because it's, as you saw, it's just if the thing is true, then keep it. Otherwise, use the old one. It's fairly straightforward logic. But we do have extensive unit tests for the usage of it, meaning the full save, upload, and merge cycle. And the way we do that is through our unit test environment, where we can control what the storage returns, and we can fail uploading, we can time out, or we can accept it, and we can simulate editing and saving by the user versus autosave. And again, we can check the flags, and we can make sure that the upload that succeeds has the correct flags and didn't lose flags because of intermediate failure to upload. Yes, it is much more involved. It is, more complex test. It is also slower test, but it is very important to have that kind of a test, because otherwise you can have regressions that is very hard to catch and find, and we don't want that. So we write the tests up front, and that's how we guarantee that it is working correctly, and it will remain so for the foreseeable future.
Makes sense. Thanks.
Thank you.
Thank you, Miklos. Raj, questions? Okay, Pedro, questions? Okay, and Skylar?
No, nothing from me. Thanks very much.
Okay, I see no questions. Thank you everyone for joining. See you next week, and bye-bye.
Thank you.